Would you believe it? The tech giant that now controls the global AI landscape, with a market cap exceeding $4 trillion, was born over an ordinary breakfast and nearly went completely bankrupt 3 times. In 1993, in a Silicon Valley diner, 30-year-old Jensen Huang and 2 former colleagues decided their entrepreneurial direction over a meal: to create chips that would allow computers to display hyper-realistic 3D graphics. nvidia was thus founded. No one could have imagined that this casual beginning harbored a legend filled with life-or-death trials. The early days of nvidia were particularly humble. The team was crammed into a small office, funds were insufficient, and the founders had to dig into their own pockets to cover expenses. In 1995, they launched their first product, the NV1, expecting it to be a smash hit. But it turned into a disaster. The chip had design flaws. It was not only expensive, but also incompatible with Microsoft's dominant system at the time, making game companies unwilling to adopt it. Within months, 249,000 out of 250,000 chips were returned, a near 100% return rate. The company's bank account couldn't even sustain it for another month, pushing it to the brink of bankruptcy for the first time. Worse, the chip market was tightly controlled by giants like Intel, leaving distributors reluctant to sell their products and investors avoiding them. Just as everyone was in despair, on the verge of disbanding the night before, Japanese gaming giant Sega extended an olive branch, a $7 million order to develop chips for a game console. This became a lifeline. However, fate's tests didn't stop. Due to significant differences in vision during the collaboration, the project was eventually halted. Fortunately, Huang led the team to Japan to apologize in person, clearly explaining the issues and proposing compensation. This transparency moved Sega, which not only refrained from holding nvidia accountable, but also paid the remaining fees. nvidia barely survived, preserving a breath of life for a future comeback. The first disastrous failure made Jensen Huang realize following a niche path would lead to ruin sooner or later. He resolutely made several key decisions, slashing the team from over 100 to just 35 core members, each capable of holding their own, abandoning their proprietary system to fully support Microsoft's dominant standard, ensuring product compatibility with most software, halting all non-essential projects, and pouring the remaining funds into one single product. The company was still financially strained, with cash on hand only lasting 6 months. Yet, Huang made another decision that the entire industry deemed insane, spending half of their money, roughly $3 million, on a cutting-edge piece of equipment, one of only a handful in the industry. While this machine could accelerate chip development, its price was enough to bankrupt a startup. Simultaneously, he personally led a team to Taiwan, China, to persuade TSMC to break protocol and skip the testing phase for direct mass production of chips. Chip development itself carried immense risk. Skipping testing for direct production meant that if any issues arose, all investment would be lost, and the company would be finished for good. The entire industry watched nvidia's joke, convinced Huang's gamble would fail. But it was this do-or-die determination that unleashed extraordinary drive in the 35-person team. They worked through the night for months, finally launching the Riva 128 chip in 1997. This chip perfectly supported Microsoft's system, offered significantly better graphics processing power than contemporary products, and was cheap. It became an instant hit upon release, selling 1 million units in just 4 months. Distributors went from rejection to actively scrambling for stock. nvidia had finally clawed its way back from the brink of death. This narrow escape taught Huang, in the tech industry, you either strive to be the best or face elimination. There's no middle ground. In 1999, he led the team to launch the world's first true GPU, graphics processing unit, essentially defining a new industry. This product swept the market upon release, not only monopolizing the high-end gaming graphics card market, but also securing the order for Microsoft's Xbox console. That same year, nvidia went public, with its stock price more than doubling on the first day. It directly became the global leader in the graphics card market, completing a stunning reversal from near bankruptcy to industry leader. After becoming the leader in the graphics card industry, nvidia enjoyed a period of stability. Gaming cards sold well, and profits grew. Shareholders suggested doubling down on the gaming sector to consolidate their advantage. But Jensen Huang had a different vision. He believed that with the future growth of the internet, stronger computing power would be essential, and traditional CPUs had limitations in this regard. GPU chips could break through these constraints and be used for broader computational work. In 2006, defying all opposition, Huang made a decision that baffled the capital markets, investing $1 billion in developing the CUDA architecture. At that time, $1 billion was equivalent to 2 years of NVIDIA's total profits. Moreover, in everyone's perception, GPUs were only for gaming. No one understood what CUDA was for. Simply put, CUDA was a toolkit that allowed developers to easily use GPUs for computing tasks beyond gaming, such as scientific data processing. This forward-looking move spooked the market. Investors felt Huang was betting the company's future, leading to massive stock sell-offs. NVIDIA's market cap plummeted 80% within 6 months, turning from an industry star into an unwanted cast-off, plunging into its third bankruptcy crisis. Skepticism was overwhelming. Industry experts publicly stated CUDA will lead NVIDIA to bankruptcy, and even some core employees left due to concerns about the future. Facing immense internal and external pressure, Huang remained steadfast. At a company meeting, he declared, "Future technological development will undoubtedly require more powerful computing capabilities. CUDA is the seed we are planting for 10 years from now. The investment we make today will yield returns in the future." But no one knew how long this seed would take to germinate, and no one expected the wait to be 6 years. During these 6 years, NVIDIA relied on its profitable gaming GPU business to sustain operations while continuously spending on CUDA R&D and ecosystem building. Several times, they nearly ran out of operating funds, barely scraping by through executive pay cuts and cost compression, surviving a difficult existence amid losses and skepticism. In 2012, a seemingly ordinary research competition completely changed NVIDIA's fate and ushered in the AI era. That year, at a top-tier global image recognition competition, a team from the University of Toronto used 8 NVIDIA GPUs to train a model called AlexNet. This model achieved an image recognition accuracy of 84.7%, far surpassing the previous best of 62.2%, a revolutionary breakthrough. The result stunned the industry. It turned out the computational power of GPUs was precisely what AI training desperately needed. CUDA, previously dismissed as a useless effort, suddenly became crucial to AI development. Soon, the AI frenzy arrived. From large corporations to startups, everyone rushed into AI, causing causing an explosion in demand for high-performance computing. NVIDIA, having invested in CUDA 6 years ahead of time, naturally became the biggest beneficiary. CUDA acted like a bridge, connecting high-performance GPU hardware on one side to global AI developers on the other. Developers could use GPUs for AI R&D without learning complex underlying technologies. Gradually, more and more people used CUDA, and its ecosystem of tools grew richer. Nearly all AI models came to be developed based on it, creating a moat competitors couldn't easily cross. NVIDIA capitalized on the momentum, launching GPUs specifically designed for AI, which were immediately snapped up by giants like Google and Amazon. Thus, NVIDIA transformed from a gaming graphics card company into the core supplier of global AI computing power, achieving a stunning transformation. All this success stemmed from Huang's seemingly crazy persistence 6 years prior. His long-term vision finally reaped its reward at this moment. With the explosive growth of the AI industry, NVIDIA quickly built a 3-layer fortress of hardware plus software plus ecosystem, leveraging its first-mover advantage to nearly monopolize the global AI chip market, becoming a veritable computing empire. Hardware, NVIDIA continuously upgraded its chips, with each new generation offering significant performance leaps. Chips like the H100 and H200 became essential for major companies training large AI models, virtually monopolizing the high-end AI chip market. They also launched a full range of products from entry-level to high-end, covering all scenarios. Software, CUDA's advantage grew stronger. Over 4 million developers worldwide used it, and its ecosystem of tools and tutorials was mature. Once developers became accustomed to CUDA, switching to other systems became cumbersome, allowing NVIDIA to lock in most developers. Ecosystem. NVIDIA built a vast ecosystem, partnering with top-tier foundries like TSMC upstream to ensure smooth chip production, collaborating with companies like Google and Amazon midstream to sell computing power as cloud services to users, and helping downstream startups and traditional enterprises with AI transformation. From research and manufacturing to healthcare and autonomous driving, virtually every field requiring AI computing power became reliant on NVIDIA. This monopolistic position supercharged NVIDIA's profitability. In 2025, revenue surpassed $130 billion, with profits exceeding $70 billion. Its market cap skyrocketed to $4 trillion, surpassing traditional giants like Apple and Microsoft. NVIDIA was no longer the small company that nearly went bankrupt, but a core force controlling global AI development. Jensen Huang was hailed as the power behind the throne of the AI era, becoming a legend in the tech industry. Just as NVIDIA seemed invincible at its peak, crisis was quietly brewing. As the AI chip market ballooned, surpassing $150 billion globally in 2025 and growing rapidly, this massive pie attracted many tech giants, officially igniting a siege warfare against NVIDIA. Google was the first to act. They ramped up production of their self-developed TPU chips while partnering with MediaTek on a dual-supplier model. Leveraging their chips' energy efficiency advantages, they specifically targeted the AI inference market, smaller in scale than training, but with more stable and broader demand. More critically, Google's TPU chips secured a massive $10 billion order from AI startup giant Anthropic, its largest hardware purchase ever, directly snatching a core NVIDIA customer. What made NVIDIA even more nervous was that Meta, a major client long dependent on it, began considering using Google's TPU chips to reduce reliance on NVIDIA and mitigate risk. Other rivals weren't idle either. AMD's MI300 chip performed well in some AI scenarios, securing orders from Microsoft and Tesla. Intel leveraged its advantage in the server market to continuously capture the mid to low-end AI chip segment. Amazon and Microsoft also developed their own AI chips, already deploying them extensively within their cloud services, gradually reducing dependence on nvidia. The capital market reacted swiftly. In November 2025, nvidia's stock price fell 23% in a single month, wiping out $620 billion in market cap. Meanwhile, the market cap of Google's parent company, Alphabet, rose by $530 billion, nearly catching up to nvidia. The once seemingly impregnable computing empire truly felt the pressure of challenge for the first time, signaling a shift in the industry landscape. Facing the joint siege from giants, nvidia didn't wait passively, but swiftly launched a counterattack with its new Blackwell architecture chips, igniting one of the tech industry's fiercest computing power wars. Huang proclaimed Blackwell as the pinnacle of nvidia's 30 years of technology. Dubbed by the outside world as the strongest consumer-grade GPU in history, this chip integrated 92 billion transistors, using TSMC's most advanced 3-nanometer process, offering significant leaps in performance and energy efficiency over the previous generation. Its biggest highlight was support for higher precision computation, enabling AI image and video generation speeds up to 3 times faster while saving half the memory, significantly reducing corporate costs. In its traditional stronghold of gaming, NVIDIA launched the RTX 50 series with the Blackwell architecture. Leveraging new technologies, it promised up to 8 times frame rate improvements and 75% lower latency, ensuring smooth 4K and even 8K gaming, further solidifying its position in the gaming graphics card market. In the critical field of AI training, the Blackwell-based GB200 chip performed even more impressively, offering 3 times the computing power of its predecessor. It allowed 576 chips to work simultaneously with faster data transfer speeds and lower latency, easily meeting the training demands of extremely large AI models, widening the gap with competitors in the high-end market. Beyond its core chip business, NVIDIA expanded into other areas, using digital twin technology to help factories and cities with digital transformation, deepening partnerships with automakers like Mercedes-Benz and NIO through its autonomous driving chips to capture that market, and expanding the application of its edge computing chips to cover industrial robots, smart logistics, and other scenarios. This comprehensive counterattack stabilized NVIDIA's position in the short term. Q3 2025 data center revenue reached $51.2 billion, a 66% year-over-year increase, proving its core strength remained intact. However, it was undeniable that the competitor's siege was having an effect. Competition in the AI chip market was intensifying, and NVIDIA's monopolistic position was no longer unshakable. From 3 near bankruptcies to building a $4 trillion computing empire to now being besieged by industry giants, NVIDIA's 30-year journey is a history of life and death struggle for a tech company, filled with perilous decisions at every step. Today, the global AI chip market has bid farewell to the era of one dominant player and entered an era of multiplayer competition. While NVIDIA's CUDA ecosystem and high-end chip technology remain formidable, competitors' breakthroughs have cracked its barriers. Google is making its chips compatible with mainstream AI tools, lowering switching costs for developers and gradually eroding CUDA's advantage. Amazon, Microsoft, and others are adopting multi-supplier models, reducing dependence on nvidia and diminishing its supply chain clout. AMD and Intel continue to make inroads in the mid to low-end market, compressing nvidia's growth space. Facing these challenges, nvidia has begun laying out its future. At the 2025 Technology Conference, Huang announced the launch of a new Vera Rubin architecture in 2026, promising 10 times the computing power of current models, along with more advanced memory and processors for further performance gains. Additionally, they are exploring the integration of quantum and traditional computing to seize the initiative in the future quantum AI era. In truth, the future competition for computing power is no longer just about chip performance. It increasingly concerns the direction of next-generation AI technology, control over the global developer community, and influence across the entire industry chain. For nvidia, this war betting on the future has just entered a critical phase. Past success is history. Can it break the curse of tech giants peaking and declining and continue writing its legend? The answer lies only with time and sustained innovation. NVIDIA's ups and downs offer a valuable lesson in survival for all technology innovation-driven enterprises.